Hello friends, this is the next lecture of this numerical methods. So in this video lecture we are going to learn what exactly the Newton-Raphson method. Okay, what is Newton-Raphson method? In the previous classes we have studied what is a bisection method. There we have tried to find out the approximate the roots of an equation or polynomial. So in this method is called Newton-Raphson method. This is the method of collaboration between Newton and Raphson. That's why they have found out how to find the root of a polynomial in an approximation way. So Newton-Raphson method is based on the first degree. Newton-Raphson method is based on the first degree equation and the first degree first derivative. So what is the exactly first degree? Suppose f of x equal to 0. This is an equation. This is an equation. It's a first degree equation in x. It means f of x is equal to a naught x plus a1. See, you can see the degree here over is 1. So when this is equal to 0, then this a1 is coming to right side, so it is going to be minus a1, and this a naught is multiplied with x. So when it comes to the right side, it is going to be divided. So this is the solution of x for this equation. Okay, so we are going to find the approximate root of this equation. This is equation 1. So if xk is the approximation to the roots, then we find the next approximation root, that is xk plus 1. So what exactly xk? See here, f of x equal to a naught x plus a1. Here instead of x you put xk. So this is going to be, suppose f of xk is equal to f of k in abbreviation form. So a naught xk plus a1 is given to us. So now what you do is you derive with respect to x. So how you derive? See, here is a naught x plus a1 is a1 is there, but what you have to do is we have to derive with respect to x. So here what happens? A naught is there. Here a naught is a constant. So dxk divided by dx plus a1. So this one will become 1. So only remaining is a naught, and a1 derivative of a1 is equal to derivative constant is equal to 0. That's why this is going to be cancelled out. Only a1 will be remained. So here you can see f dash of k is equal to a1. Okay, you can see f dash of k is equal to a1. So equation 2, this is equation 2, and this is equation 2, and this is equation 3. So equation 2 can be written as f of k is equal to a naught xk plus a1. But what is a1 a naught exactly? A naught is nothing but f of k, f dash of k. So here instead of you can see here, you just keep as it is. So here a naught k plus a1 is equal to f of k. So a naught you can see a1 is equal to f of k minus a naught k. It's going to be like this. So now a1 is equal to f of k minus, what is exactly a naught? A naught is nothing but f of k. That's why f of k you have to replace here, non f dash of k into k. Okay, so that's what it is written here. So now you have to put this equation 4 and equation 3 in the desired solution. We get like this: xk is equal to minus a1 divided by a naught. So we have xk plus 1 is equal to minus f of k minus f of divided by f of xk. So here f dash of f of k by f dash of k minus this is going to be cancelled. So minus plus f dash of k into xk divided by f of xk. So here this is the final answer. So you have to remember this formula exactly. What is this? Xk plus 1 is equal to xk minus f of k divided by f dash of k. What is f of k? F of k is nothing but the functional value at xk. This is the one, and f dash of k is nothing but f dash of xk. Okay, so this is the necessary formula for the Newton-Raphson method. So note that Newton-Raphson method should be used only when f of x is a large in the neighborhood of a root of f dash of x is not equal to 0. So you can see here the f dash of k is in the denominator, so this should not be equal to 0 at that point. And to locate the root of this one f of x equal to 0, guess two number a and b. we have to define this two number a and b such that f of a and f of b are in opposite sign. It means if f of a is a positive number, then f of b must be, the functional value must be negative, or if f of a is negative, then f of b must be positive. Then only this condition will means we can find the root. So that the root of f of x lies between a and b. Okay, the root of f of lies between a and b, and f of a must be greater than 0 numerically. Then a should be taken as the root from which the start, otherwise b should be taken as the starting value. So we are going to see exactly what is the algorithm. Okay, working algorithm. Here you can see algorithm. Find the points a and b such that a is less than b and f of a into f of b must be less than 0. Okay, so suppose this is our what coordinate system. You can see here a, you have to find a and you have to find b such that f of a, it has to be like this, otherwise it has to be like this. Then only we can go for the approximation of the value. Then what is step 2 says that take the interval a b, माने जो a और b और interval, take the interval a or b so that you have to find the a plus b by 2 like bisection method. So after finding, you have to put this value in that function f of a plus b by 2. Then you have to find the what, here you can see you have to find the functional value at x naught and f dash of x naught you have to find. Then x1 is equal to x naught minus f. This is the formula. This is the Newton-Raphson formula. This is a Newton-Raphson formula. Okay, so now, so what step 4 says, after finding x1, you have to put the value of x1 in that function and you check whether it is 0 or something else. If it is equal to 0, then x1 is a exact root. If it is not equal to 0, then you have to what, assume that x0 is equal to x1. Then repeat this step 2 to 4 again and again until we find the solution. Okay, now we will see the example here. Here example says that find the root of an equation f of x equal to x cube minus x minus 1. This is the what, this is the polynomial which is given to us. So we are going to solve the polynomial. Means what exactly the meaning of solving is, we are trying to find the root using the Newton-Raphson method. Okay, so now you let f of x equal to x cube minus x minus 1. So, and you have to find the derivative of this function. What is this? X cube minus x minus 1. This is the original function. So after finding the derivative, so this is going to be what, 3 into x square minus, what is the derivative of x? 1, and derivative of 1 is equal to 0. So 3x square minus 1 is the what, derivative. So here it is given to us. So now you have to put what is the functional value at 0. It means this is the function. Instead of this x, you have to put 0. So you have to put 0, you have to put 0. So it is going to be 0 minus 0, 0 minus 1. So this is the answer, minus 1. Okay, we got it now. Now you have, instead of x, you have to put 1. When you put 1, here is 1 cube is equal to 1 minus 1. 1 minus 1 is equal to what, 0, and here minus 1 is given. So answer is minus 1 here. Okay, now you put, instead of 2, x2, you have to put 2 cube minus 2. So 2 cube is equal to what, 8 minus 2 minus 1. So 8 minus 2 minus 1 is equal to 5. Okay, so this is positive. So here when you are putting x equal to 0, then you are getting f of x equal to minus 1. When you are putting x equal to 1, you are getting the value minus 1. When you are putting x equal to 2, you are getting the value 5. So here you can see that f of 1 means, sorry, f of 1 is equal to, this is a negative value, but when you put 2, this is a positive value you are getting. That's why our root lies between 1 and 2. Okay, so 1 and 2 is the, so here a is equal to 1 and b is equal to 2. So what happens here is, we are going to find what is x naught. X naught is nothing but 1 plus 2 by 2, that is equal to 1.5. Okay, now our first approximation is 1.5. So what is the algorithm says that? Your algorithm says that you have to put the value f of x naught. Okay, when you are putting f of x naught, you can see here f of x naught is equal to, when you are putting 1 point here, what is the equation exactly says that? X square minus x minus 1, right? So instead of x, you put f of 1.5. So 1.5 square minus 1.5 minus 1. After putting in calculator, you will get 0.875. Okay. So now this is the one. Now what you have to find f dash of x naught. It means f dash of 1.5. What is that? 3x, sorry, xq, right? That is 3x square minus x. So 3x square minus 1, sorry. So 3 into 1.5, 3 into 1, sorry, 3 into 1.5 square minus 1. So after doing that, you will get this one answer. So now this is the Newton-Raphson approximation, right? This is our first approximation. So you have to put x naught minus f of x naught divided by f1 of x naught. So what is x naught exactly? That is 1.5. And what is f of x? F of x we have got here 0.875. Okay. Now what is f dash of, means f prime of 1.5? That is 5.75. So after calculating in calculator, means to solve this engineering mathematics, you need to have a scientific calculator for examination, so you don't have to worry about calculations. What you have to do is you have to know how to operate that machine, means the calculator machine. So after doing the first approximation, we have got is 1.34783. Now we go for the second approximation. So we have got this answer we have got this answer what, 1.34785, 783. Now you have to put in that equation. What is that equation? X cube minus x plus 1, sorry, x cube minus x minus 1. In this equation, you have to put, instead of x, you have to put 1.34783. So after that, you will get this value. Again, you have to find f prime of x1, you will get this value. Now you put again in that x2. Now since this is going for second approximation, so x2 minus x1 is equal to, x2 is equal to x1 minus f of x1 by f dash of x1. This is the second approximation of Newton-Raphson method. So you put that value, then you will get this much answer. Okay. Now you go for the third approximation here. This is instead of x, you have to put 1.3252. Then you will get this one. Then f dash of x2 you have to put again. You will get this one. So x3 is equal to x2 minus f of x2 divided by f dash of x2. This is again the Newton-Raphson method of third approximation. Then eventually you will end up with this solution. Now you go for the fourth approximation. See, this is the x3 we have got. Okay, this is the x3 we have got. So now f of x3 is equal to, you are getting 0 here, but f dash of x3 we are getting this one. So the fourth approximation is equal to, this is the formula of Newton-Raphson method again. So x4 is equal to x3 minus f of x3 divided by f prime of x3. So here this is 0 by anything is 0. That's why x4 is equal to 1.32472. Okay. So the approximate root of the equation x cube minus x minus 1 equal to 0 using Newton-Raphson method is, the final answer is 1.32472. Okay. Now you can tally in this table when n is equal to 1, 2, 3, 4. Okay. This is a fourth approximation. Xi, the xi value, first approximation is 0.5. This is x not equal to 1.5. So eventually in the fourth approximation, these are the roots. Okay. I hope that you have understood this one. If you have any doubt, you can ask me in the comment box. Otherwise, you can call me in my WhatsApp number. And if you haven't subscribed already, then please do share, subscribe, and like, comment. Okay. Thank you.